So here we have our map sensor where we just verified that we have our pink wire is going to have the 5-volt reference, which is shared between a few different other sensors: our throttle position sensor, our camshaft position sensor, our crankshaft position sensor, and we also have it to where our blue is going to be our ground, and then our purple is going to be our signal wire.
All right, so today we're working on this '07 Grand Caravan, and we're going to be looking at our map sensor. It's a 3-wire sensor. We've got power on this pink wire, ground on this blue wire, and this purple wire is going to be our signal. All right, so we've got our map sensor unplugged, and we're back probed into the purple signal wire. And as you can see, we've got 4.89 touching almost 5 volts with the engine off, key on. So here we've got the vehicle idling. And you can see it's pulling about 20 inches of mercury, and our voltage is right around the 1.15 mark, going up and down just a little bit. If I open the throttle real quick and load the intake manifold, you'll see that our vacuum is going to drop and our voltage will go up.
Alrighty, so we're just going to show that as we increase RPM, our pressure increases gradually. So right there, we got up to about, I want to say 2,000 RPMs, which got us to about 5.3 PSI. And then as we let off, it dropped to about 3.3 PSI. And we're back now idling.
All right, so here looking at the picoscope data, you can see this is, we're looking at the signal wire on our map sensor. Our base voltage at idle is around the 1.1 volt number. And as you can see here, we open up the throttle, and our voltage increases due to the load. All of the air that's going into the manifold is going to increase the pressure, and it's going to sit up there for just a second until RPM catches up, which will then bring that voltage back down, and you can see it actually goes underneath our idle, meaning we've got more vacuum than we did while we were at idle, and then it'll slowly bring itself back up to that 1.1 mark.
All right, so as we increased, we just rolled on the throttle just a little bit. Our voltage stayed the same at around that 1.1 line. And then as we got a little bit closer to a higher RPM, around 2,000 RPMs, it just started to go below the line. So we had more vacuum pressure than we did when we were at idle originally. And then letting off the throttle is just coming back up to that 1.1 line. And then it just evens itself out. Today we are working on Owen's BMW 330i. We are going to be looking at the mass airflow sensor. It is a hot film mass airflow sensor where it shares power between the camshaft position sensors and the MAP cooling thermos. The black wire is going to be the ground. We have the signal wire, which is the yellow, and then our red and white is going to be the power split between the camshaft position sensor and the MAP cooling thermos.
All right, so we've got our voltmeter here onto the signal wire of our MAF, and you can see with key on, engine off, no air moving through it, it's going to be at about its lowest reading, which is going to be 0.11 volts.
Alrighty, today we are working on Owen's BMW 330i. We have set up the picoscope to the signal wire and to a ground. We're currently idling around 1 volt, and we had, with just key on, we had about 0.1 voltage. As we increase the engine RPM, we should see the voltage go up. Engine RPM increases, we shot up to about close to about 2 volts there, and then it settles back down at 1 volt for idle. So right now we're about to do a demonstration where we just kind of roll on the throttle, see if voltage increases as RPM increases. And as you can see, as we increased our RPM, the voltage started to go up significantly. Our second one, we're about to just get up to about 2,000 RPMs and hold it. And as we held at 2000 RPMs, we had a stable line of voltage, I want to say about 1.6 volts. And this last one, we're just going to goose it. And as you can see, it jumped up to about, I want to say 3.8 volts.
So I'm sitting in the vehicle. As you can see, I've got my PID set up here on my head unit. I've got bank 1 and bank 2 short-term fuel trims here, as well as my mass airflow rate. Right now, everything is as it should be. We've got no unmetered air leaks or anything, and you can see my fuel trims are looking pretty good. Honestly, kind of plus or minus 2%. And our mass airflow rate is around the 1.1, 1.2 pounds per minute mark. So now we've got this vacuum line disconnected. It goes onto this little F connector here, and which is in the intake boot. So we're creating this unmetered air leak, and we're gonna see how that affects our MAF readings as well as our fuel trims. All right, so here we are looking at our PIDs again with our unmetered air leak, and you can see the fuel trims are around the 2 to 3% mark, which is a little bit higher than they were previously. And our MAF rate is honestly a little bit lower, around the 0.9, 1.0 mark, where it was previously at 1.1, 1.2 pounds per minute. You can see the fuel trims have gone up because there's unmetered air entering and it's causing a bit of a lean condition, so the PCM is going to have to correct and add a bit of fuel.
So here we've unplugged our MAF sensor, and we're going to see if the car runs without it.
Let me know when you're ready.
Alright, so we just saw that the car tried to start up, but it wouldn't.
Behind that.
As you saw, without the MAP sensor, the car wasn't able to run. This car doesn't come equipped with a MAP sensor, so it doesn't have a backup. Since this is such a powerful sensor, without it, the car won't be able to run. Alrighty, so right now we have our MAP sensor sitting at 1.2 volts on idle, and we're about to create a cylinder misfire. Now that we've created the cylinder misfire, we're still sitting at 1.2 volts. With it plugged back in, the voltage has dropped